Okay, so our final step in this whole graphing process that we're going to bring together tomorrow and practice for 3 days and then test on it on Friday is limits as x approaches infinity. Okay, so x approaches infinity is going to be out. What kind of asymptotes go out? Horizontal. Okay, so it's our test for horizontal asymptotes. So just to remind you that, if I got my limits, I'm going both ways, right? My x's are going smaller. I'm going this way. And I'm going this way. I'm going out there, right? And they are both approaching 3. Okay, so how does that happen? So we need to talk about how that is happening. So if I'm taking the limit as x approaches infinity of 3x squared over x squared plus 1. So I want my x squared is getting larger and larger and larger and larger and larger and larger. Yes? Yes. So I have 3x squared. So let's say 3 times 1, 2, 3, 4, 5, 6. Okay? Over what's that pretty close to?
Aren't they supposed to not have the same numbers?
Yeah, because they're both x squared. So I'm taking 3 times this number. Oh, that one shouldn't have a 3 on the bottom. Yes. So I'm taking 3 times the number on the bottom that's plus 1. So essentially, these two things are pretty much a wash, correct? 100 million plus 1 is pretty much 100 million, yes?
Yeah.
Okay, so my answer would be just what?
3.
3. It wouldn't be exactly 3, but would it be pretty darn close to 3?
Yeah.
Yeah, because these two other numbers, I mean, like I said, 100 million and 100 million plus 1, essentially the same thing when we're all looking at it from that big of numbers as we get larger and larger and larger. So what happens if I go to negative infinity? Well, I'm squaring it, yes? So is the same exact thing going to happen? Yeah, because I'm squaring them. So both of these things as we approach negative and positive infinity are both approaching 3, and that's how. I didn't have to do the math, I just had to think about what was happening. Okay, so what this says, just the horizontal asymptote basically is the limit as I approach negative infinity and positive infinity. That's all it's saying. Now, the limits at infinity, we need to talk about. The next one is with positive infinity and negative infinity, and it shows some constant over a variable to some power that's positive, and both for negative and positive infinity is 0. So we need to talk about why it is 0. And if I was writing it, I would just say the limit as x approaches plus or minus infinity of c over x to the r is 0. That's how I would write it. I wouldn't write that it's two different things. Okay. Now we need to rationalize this in our brain and why it is 0. Okay. Oh, I got a yawn too. So think about what's happening. So if I have some number, let's say 15, and I'm dividing it by infinity. Evidently, I chose red on red. What's happening? 15 divided by infinity. Is my numerator changing? No. My numerator is not changing, but what's happening to my denominator? It's getting what? Really big, right? So if I take a relatively small number in the grand scheme of infinity and I divide it by a huge number, what is it essentially? 0. Yeah? So if I have 1 divided by all of this, there's no point even doing that, is there? It's 0. It's approximately 0. Does it change if I do that to a negative? No. Because there's no negative 0. So do you understand why if that denominator is infinity, what if I had infinity, I had x to the r plus 1? Would it matter?
No.
When you have infinity plus 1, is it going to change it? No. It's still going to be infinity. I mean, it's still going to be 1. I can't talk. 0, yes? Make sense? Okay. So it says find the limit as x approaches infinity of 5 minus 2 over x squared. So we should remember from our limit days that this is the limit of 5 minus the limit of 2 over x squared, correct? I get lazy and I don't keep writing my approaches. So what is the limit of any constant number?
Would be infinity.
Well, no, it's 5. There's nothing to change, right? So it's 5. Minus. Now what's the limit of 2 over x squared going to be? 0. So the answer is what?
5.
5. So that was approaching positive infinity. What happens if I approach negative infinity? Anything?
No.
So this is as x approaches positive infinity. And as x approaches negative infinity, I'm still going to get 5 minus what? 0?
0.
So it's still going to be 5. So when we would graph this, at 5, it would be a horizontal asymptote of this graph. Now remember, horizontal asymptotes only go to infinity, so do they cover anything in the middle? Nope.
No.
Okay. How about this? Well, if I think about it, I'd put infinity, 2 times infinity minus 1 is still what? Infinity, right? And infinity plus 1 is still what? Infinity. So the answer would be what?
Would it be?
It'd be infinity.
What about the 2?
Hmm?
The 2 doesn't do anything?
Well, it's 2x. It's not just 2.
So,
It just makes it bigger.
if we were multiplying 2 times infinity, it's still infinity. I don't like this.
Okay? So what happens if I put a negative?
Negative infinity?
Well, you'd have a negative over a negative, wouldn't you?
Then it's still infinity.
Still infinity. Okay, so that did not do me any good, did it? Okay. Do you guys remember when we used indeterminate for this? It's an indeterminate solution. We don't know. Okay? So if it's indeterminate, we have to figure some other way to do it. So what we can do when we get an indeterminate solution is we can divide everything by the highest power of x, or the variable, in the denominator. Okay? So the highest degree of x, or whatever variable we're using, in the denominator. So what is the only degree? 1. But we have to divide everything. You understand? So we get 2x divided by x minus 1 over x all over x plus 1 over x.
Oh, because you divide everything.
Yeah, everything.
So if it was like x squared in the denominator.
And so you would divide everything by x squared.
Like that.
Mm-hmm. Okay, so this is going to give us the limit as x approaches infinity of 2 minus 1 over x over 1 plus 1 over x. Yes? Yeah. So based off of what we just did up in this first example, what's the limit of the numerator?
Of the which one, sorry?
The numerator.
Of infinity.
No,
Negative infinity.
no. It'd be 2 minus 0. Yes?
Wait, why is it 2 minus 0?
What did we just do up here?
Oh, we divided it by infinity.
Yeah. So 1 divided by infinity is 0, yes?
Yeah.
So we get 2 minus 0. And in the denominator, what do you get?
1 plus 0.
1 plus 0. So what do we get? 2. So would that change if I went to negative infinity? No, because the 2 and the 1 wouldn't change, right? So both the left and the right on here have a horizontal asymptote at 2. Do you guys remember how we found our horizontal asymptotes last year?
Not like this.
We didn't like this, did we?
No.
But how did we do it? Do you remember?
That was a long time ago.
You disappoint. You disappoint. Let's do these limits real quick before I ruin your... Okay, so all of these, aren't they going to give me... Well, no, maybe not. Well, no, think about it. If I put infinity into the numerator, I'm going to infinity over infinity squared. So I'm still going to get what? Infinity. So I'm going to have to divide by what? X squared.
Okay, so here's a silly question. It doesn't matter what degree or what you multiply infinity by, it's still just infinity.
Yes.
Okay.
Yeah, it just gets there quicker. Okay, so after I reduce, what are we left with? Oops, I forgot my x, didn't I?
So 2 over x
So I'm left with 2 over x
plus 5 over x squared. Over 3 plus 1 over x squared.
Okay, so when I started out, I had infinity over infinity, yes? Okay, so now, as I'm doing this, let's see. Well, this is going to be, what's 2 over x going to be?
That stays infinity.
Mm,
Like 2 over?
yeah. So 2 over infinity is?
Infinity.
No. 2 divided by an obnoxiously huge number is 0. And what's 5 over infinity squared? 0. And 3 is 3. Plus 0. So 0 divided by 3 plus 0 is 0.
This is a trick.
So next one, I'm still going to get infinity over infinity, yes?
Yeah.
Okay. And I'm going to divide it by what now? X squared. And I'm not going to write all my steps anymore. I'm done. I'm over it.
No, it's just the
So-
highest degree in the denominator.
Yep. Highest degree in the denominator. I don't care about the numerator because I can divide by, I can divide 0 all day. Can't I? Okay, so 2x squared divided by x squared is 2. Plus 5 over x squared over,
3 plus 4 over x squared.
okay. So 2 is 2, right? And 5 over x squared is 0. And 3 is 3. And 1 over x squared is 0. No, it is not.
Oh, wait, no, it's not. You're right.
This one got 2/3. Okay. So I'd still get infinity over infinity on the third one, yes? Am I going too fast? Sorry.
Change it.
What's changing about these guys?
We're getting exponents.
The exponent in the where?
Numerator.
Numerator. So this time I'm going to still divide by what? X squared. But I'm going to get what this time? Two x cubed is going to be what?
It's just gonna be
2x
yeah.
plus 5 over x squared over 3 plus 1 over x squared.
Yeah.
Oops. What's going to be our problem this time?
It's gonna leave an infinity.
It's going to leave infinity in the numerator. It's going to be infinity plus 0 over 3 plus 0.
Yeah.
So infinity divided by 3. So the limit not coming back to you yet about how we found horizontal asymptotes.
You plug. You plug.
We never did in limits last year.
Well, give me a second. You did. You plugged a number into the whole thing. You plugged 0 in. You set the whole thing equal to 0. You divided by.
Okay. So let's look what the difference is between all three of these. So I have 2x and 3x squared.
The difference.
I have 2x squared and 3x squared. And I have 2x cubed and 3x squared.
Yeah. So it's
What is making the difference here?
the exponent in the numerator.
The exponent in the numerator.
Yes.
Still not coming back.
Oh my gosh! Can you just tell us?
Okay, if the degree of the numerator is less than the degree of the denominator, 1 and 2. Okay, see that? Degree of the numerator is 1, degree of the denominator is 2.
Oh, you're supposed to be on this page. Okay.
Yes, I'm going back and forth.
Okay, I get it.
If the degree of the numerator is less than the degree of the denominator, the limit is 0. This doesn't sound familiar. Replace limit with another word to
Coefficient.
horizontal asymptote.
The leading coefficient.
Yes, we're testing the leading coefficient, but not yet. We're okay. If the degree of the numerator is equal to the degree of the denominator, go back to your work. What was your answer? It was the ratio of the leading coefficients is the limit, aka the horizontal asymptote. If the degree of the denominator is, if the degree of the numerator is greater than the degree of the denominator, what is your limit, aka horizontal asymptote?
It does not exist.
It does not exist. But, do you remember the but?
Confusing me. If it is exactly one less.
One more.
One more.
There is a
The
slant.
sideways one. The slant.
Good job. There's a slant.
I remembered something, but now you gotta give me a second to write this down.
Okay.
I'm too fast.
And these say limit, but otherwise known as the what? Horizontal asymptote.
Is equal to.
And those are all on that sheet that you have that describes how to graph rational numbers. And we'll do our 3.0. It's our but. If the degree of the numerator is 1 more than the degree of the denominator. I have D of D, that looks weird. Then there is a slant horizontal asymptote found using what? Anybody? Your favorite thing.
Why are you like this?
Now, you aren't going to have to do the 3.0, the but, okay, today. You will have to do it when you're graphing. It will occur. Because today, all you're doing is find the limit. So it will say it doesn't exist. If you want to practice your long division, so if it's one bigger, you can practice your long division. You could do that.
This is bringing back flashbacks.
PTSD.
Yes.
I don't know if that's a thing. Math PTSD.
I have it.
No, you don't. Math brings back warm and fuzzy feelings.
Sorry, you had me so confused. You were saying so many words at the same time I couldn't write.
Are you good?
Yeah, you're good now.
Okay.
Is that all we're doing?
Basically. You're just going to find the limits with different... They're the same equation. One's negative and one's positive.
Does it
Not really. Okay. Well, I pretty much think we'd have an indeterminate solution there, don't you? So 3 times infinity minus 2, that'd be infinity, yes? And 2 times infinity squared plus 1, the square root of that would still get to infinity. A little slower, yeah? But would it still get there?
Yeah.
So that's not going to help me out, is it? So this is kind of weird. Did it switch? It did, didn't it? So we are going to divide by the square root of x squared. Because technically the power... Does that make sense what I'm saying? Actually, just don't even pay attention to it. I'm just going to do it this way. The book shows it as the square root of x squared. I'm just going to tell you to no, we have to. Okay, so I have 3x minus 2. I'm going to leave a gap. We're going to come back up and write that. But I'm going to show you what I meant by the bottom. So if I have the square root of 2x squared plus 1, and I want to divide that, what I'm dividing by, doesn't it have to be in a square root for me to mathematically do it? Yes?
Yeah.
So I'm going to be dividing by the square root of x squared. Well, what is technically the square root of x squared? Just x. So up here, we're going to be dividing just by x. But down here, it's going to look like the square root of 2x squared over x squared plus 1 over x squared. Does that make sense why that is? Because when you divide the radicals, they just join to be 1. Okay, so 3x over x becomes 3. I forgot my limit. We're going to do x approaches positive and negative infinity, right? So I get 3 minus 2 over x. And your denominator would be the square root of what?
2 plus 1 over x squared.
Okay. So 3 would be 3 minus 0 over the square root of 2 minus 0 or plus 0. So I think that gives me 3 over the square root of 2 or 3 square root of 2 over 2. Now, is that going to change if I do everything to negative infinity?
No.
No. So that is my answer for either positive or negative infinity. I don't know. Okay. I'm not going to do any trigonometric. I'm going to be nice to you.
That's so sweet.
I know.
Sure you get that a lot.
I don't really want to switch to my camera. Can I just disregard this? I'll just handwrite stuff. Okay, so if I had, we're just going to put definition. Of infinite limits at infinity. I'm going to abbreviate. So if I said the limit as x approaches infinity of f of x equals infinity. So we're saying that if it's approaching infinity, this assumption is positive infinity, correct?
Yeah.
And this is why I write positive infinity myself. We are saying for every x, there's an f of x that is greater than it, right? So it is also, they're approaching positive infinity, so positive numbers. So if I have the limit as x approaches negative infinity of f of x equals negative infinity, we're approaching what? Negative numbers. So negative number. So this one is going up and this one is going down. Actually, and I should write it not that way. I should write it this way from left to right. I should be going down. Yes? Okay. So I just want to make sure that is a clear statement to you. Does that make sense? So if I have the limit as x approaches infinity of x cubed, what is that going to be? Infinity, positive infinity, to be exact, yes? So as I go out on my x-axis, my y's are going what? Up. Okay, so what if I do the same limit as x approaches negative infinity of x cubed? It's approaching negative infinity. So as my x's are coming out, my y's are what? Going down. Now, you know what x cubed looks like, yes?
Yes.
Looks like this. Is that a correct statement on what we found? Okay. So, guys, shut the door. Stay out and shut the door. Okay. So I just wanted to show you on a basic one. So if you do hit those, you need to think about it. Okay? There are a few more examples in the book, but actually there's one more example in the book. But I think we've got everything covered. All you are doing today is limits at infinity. Over and over and over and over and over.
See, I like the part where we just assume